So how does this magic thing work? We have some data to learn from, and our task is going to be to predict whether or not I like a bottle of wine. So what we have here is the correct classification for 50 bottles of wine, a red Y for yummy and a blue no for not so yummy. And I have the age of the wine in years and the opinion of some amateur wine critic friend of mine on the y-axis here. And the game here is to find and exploit patterns in data. So look at these data and tell me when you see a pattern that you can exploit. Something to separate the yeses from the nos. That's the game. So can you do it? You come up with a recipe that separates them? Nod when you see it. Nod when you see it. All right, I see some people who are finding it. Very nice. And now I have to own up that it's all a trick. Actually, these data, I made them up, and I made them up completely at random. So I know that there are no patterns here. And if you're finding patterns that are sort of spirally or circular, and you think you've got some story that you can base a recipe on, that's your beautiful human mind finding Elvis's face in a piece of toast. Our brains do that. We find patterns that aren't actually there, and then we think that we've got a strategy that we can exploit, and things go wrong when we try to use it. Now, machine learning can do exactly the same thing. Find patterns that are not there. And then if we base our solutions off of those patterns that aren't there, of course things crash and burn. So the approach that we take to protect ourselves, and we'll talk about this a lot today, it's the same approach that we should actually get in the habit of taking with our own human intuitions. Don't take it seriously in the piece of toast where you found Elvis's face. Try it on a new piece of toast and see if the face is still there. So try it in the new data, see if that recipe still works. Whether it comes from a machine or from a human, that's the part that keeps you safe. Okay, enough messing about. I generated these data and I promise you that there is a pattern in here. How would you exploit this pattern to help me classify new bottles of wine? How about you put a line through it, and that line is a wall that separates the red region from the blue region, and off we go. Sounds good? That's pretty much what machine learning does. Now, that boundary does not actually need to be a line. Those gobbledygook algorithm names, which we'll meet later, the main difference between them is the allowable shape of the boundary that the thing is trying to shove through your data. So if you pick this one, it's going to try to put one single line, and that line can have any slope. With this one, now it can use many lines, but the only slope options are thus and thus, vertical and horizontal. Or you can have a real nice flexible squiggly thinger, which we call neural network. And once you have picked the algorithm and the allowable boundary that's represented by it, then what it's going to do is, based on where your data lie, it's going to try to find the most sensible place to put that allowable boundary. So it's going to try to contort itself to your data, subject to the sort of thing it's allowed to be. So say we pick the line, and we run it. Oh, there we go. There's our answer. And what comes out of this is what we've wanted all along, a model. Now, a model is just a fancy word for recipe here. Just a set of instructions to take inputs, turn them into outputs. And our model reads, if we're in the red region, call it red. If we're in the blue region, call it blue. Job done. And so in comes a new bottle of wine. Red or blue? Red. But we could have chosen a different algorithm. There we go. Let's pick the tree and run that thing. Here is our recipe. And that's a different recipe from the previous one, right? And in comes a new bottle of wine. Blue. Troubling. Most troubling.